Hello, welcome to my video on data structures. In this video, we will implement the merge operation. We will also test our implementations to see if they behave as expected. Let's begin with the merge operation. The merge operation tries to merge two arrays into one. Imagine if two online retail stores decide to merge, and they want to combine the items they sell into a single array. We can use the merge operation to achieve the goal. Note that the merge operation is not a standard operation for the array data structure, but it will facilitate our understanding and motivate the future study of other merge-efficient data structures. We will implement the merge operation with the following four steps. Given two arrays A and B, we first obtain the sizes of them. Second, we change the size of array A to the total size of A and B. Third, we move the data elements from B to A. At last, we clear all data from B. Note that we clear data in B to avoid holding redundant data. The time complexity of the merge operation is linear to the total size of A and B. When we resize array A, we may need to move all data elements in A, and in step 3, we also need to move all elements in B. Together, they lead to the time complexity of big O, A plus B. Let's look at the code. The function takes in one parameter right-hand side, which is the array to merge with, or the array B as we mentioned in the previous slides. In the code block from line 3 to 6, we check whether the array is trying to merge with itself. Because it is an unexpected use of the operation, we will return and do nothing. In line 7 and 8, we access the sizes of the two arrays to be merged. Note that we will need to record the original size of the array A in line 7, which serves as the offset for placing the elements in B into the merged array. In line 10, we resize array A to the total size of A and B. Then, in the for loop between line 11 and 14, we move the data elements from array B to array A. Note that the indexes of the elements are all offset by the original size of array A. Finally, in line 15, we set the size of array B to 0, implicitly clearing the array. Okay, let's move on and test our implementation. Here I generated an arbitrary list of numbers shown as the figure to the left of the code. And then we read in the numbers one by one. In line 8, we print the capacity and size of the array after each data insertion. Here is the output. We find that the size of the array is increased by 1 each time, as expected, but the capacity does not seem to be an exponent of 2. The reason is, although we try to make the capacity twice as large as the requested size each time, the requested size has included a new element to be inserted and itself is not an exponent of 2. For example, when we insert the fifth element, the existing capacity and size of the array are both 4. As we are inserting a new element, we will try to resize the array to 5. In this case, the new capacity, which is expected to be twice as the requested size, is set to 10. Then, let's check if the data are properly stored. We simply use the data access operation at to print all elements stored in the array. We compare the output with the input and confirm they are identical. Now we try to modify a data element using the data access operation. In line 2 of the code, we try setting the fourth element in the array to 55. Note that the array is 0-based, so index 3 actually refers to the fourth element. We then print the array after the modification and indeed see that the fourth element is updated to 55. Then we will test the data insertion operation by inserting 88 at the third position of the array. After the insertion, we can see that 88 is indeed inserted into the third position, and the rest of the data elements remain the same but shifted by one position. For data deletion, let's try deleting the 10th element. After the deletion, we see that 98 disappears, while the rest of the elements stay the same. At last, we will test the merge operation. We first print out the two arrays to be merged. The first one is the array that we have been dealing with so far. The second one consists of numbers from 1 to 10. First, we try to merge with the same array. As we can see, as expected, nothing happens. Then, we merge the two different arrays and print both arrays after the merge. We can see that the first array now holds all 20 elements, and the numbers from the second array is placed after the elements from the first array. The second array now contains nothing, which is shown as an empty line right here. In summary, we have shown the implementation of the merge operation in this video, and we have tested our implementations to show that they behave as expected. This is also the last video for the array data structure. In the next video, we will discuss a new data structure called linked list. Thanks for watching and hope to see you next time.